Friends, welcome back to my channel. In this video, we shall learn the concept of refraction of light, which is related to the Gpstr exam 2022 and which also will be useful for TET and Central TET exams. Before moving to the concept, if you are new to the channel, do subscribe and press the bell icon so that you will get the notifications of all the videos we upload here related to Gpstr exam, TET and Central TET, mainly of maths and science concepts. Let's move into the video now. Refraction of light. The change in the direction of the path of light when it passes from one transparent medium to another is called as refraction of light. The change in the direction of the path of light when it passes from one transparent medium to another. As we can observe in this image, a glass container filled with water partially and a pencil is dropped into it. We can observe here that when the pencil is a part of pencil which is above the water level seems as straight. It is straight, but the pencil which is inside the water, it seems as if it is bent. Why this is so? So this is because of refraction of light, means bending of the light when it passes from one transparent medium into the other transparent medium. Here there are two mediums, one is air medium, the other one is water. Both are transparent medium, but when the light ray travels from one medium to the other medium, it changes its path or direction. You see, actual path of the light ray, if suppose we have to consider that its light moves in a straight line, it's supposed to be like this, but the light do undergo refraction when it changes from one medium to the other medium, or when it travels from one transparent medium into another transparent medium. And this is the ray diagram for that. And here there are two mediums considered, air medium and water medium. And air medium is the rarer medium and water medium is the denser medium. We can call, comparatively we can call them as rarer and denser. Air is rarer comparing with the water. Okay, remember this, rarer and denser. And this is the boundary of the two medium, and we can draw the normal to the boundary, a perpendicular drawn to the boundary of the two substances or two mediums, medium 1 and medium 2. And this forms 90 degree with the boundary, and this is the normal line. And you can observe the incident ray, the ray which falls on the surface or the boundary of the two medium on incident with the normal where it meets the boundary. This is the incident ray, and the light ray which bends after passing through this medium is called as refracted ray. The angle between the incident ray and the normal is angle of incidence, or this is also called as incident angle. Okay, angle of incidence or incident angle. And the angle between the normal and the refracted ray is called as angle of refraction. So this is represented by small letter r. As in case of reflection also, we represent angle of incidence and angle of refraction are I and R respectively. Don't get confused. Okay. So few points here to be noted are, when the light ray moves from rarer to denser medium, it bends towards the normal. And when the light ray moves from denser to rarer medium, it bends away from the normal. Why it is so? It is because of the speed of light. When the light ray moves from rarer to denser medium, its speed decreases. Hence it bends towards the normal. In the other case, when the light ray moves from denser to rarer medium, its speed increases and hence it bends away from the normal. In this image we can observe that the light ray is moving from air to water. It means it is moving from rarer to denser. So you remember rarer means the molecules are very rarely packed, so easy for the light to pass through them. And if it is a denser medium, molecules will be closely packed, right? Little more than the rarer medium, and for the light to pass through them is little difficult. So you can remember this point. And when it moving from rarer to denser, the light ray bends closer to the normal, towards the normal, closer to the normal. So this is the normal here and the light ray. But when we trace the actual light, this is the incident ray. If this dotted lines represent the actual path without refraction, if it was the light, it should have passed straight. But since the light ray is undergoing refraction, it is bending. So how it is bending? It is bending towards the normal. Remember this. When it passes from rarer to denser. But when the light ray passes from denser to rarer medium, look at the aroma. Denser means water to air. Here they have taken. So when the light ray passes from denser to rarer medium, it bends away from the normal, from the actual line. You see, the actual path of the light ray, suppose this is the light ray, and without refraction, if the light ray is moving, it's supposed to go straight, but it is bending. Whether it is bending either right or left or towards or away from the normal depends on the speed of light, as we saw, and it is bending away from the normal in case of light ray moves from rarer to denser to rarer medium. Okay, denser to rarer medium, away from the normal. Clear? Next, what causes the refraction of light? It's because of change in the speed of light that gives the effect of refraction of light. Remember this. Let's move to the laws of refraction. This is also called as Snell's law of refraction, or Snell's laws we can call it. The first law of refraction says that the incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane. So Snell's first law says that the incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane. So this is the boundary or the plane. So this ray, incident ray, refracted ray, and the normal all lie in the same plane at this point. Okay, so this is first law of refraction, or Snell's first law. Then second law of refraction, the ratio of sine of angle of incidence I to the sine of angle of refraction R is constant for the pair of media. So sine I by sine R, sine I by sine R is equal to constant. We can express this mathematically like this. So this constant value is written as mu. Sine I by sine R is equal to mu, where mu is called as refractive index. And few more important points we have to note down here. The frequency of light depends on source of light. For example, which is the main source of light for the solar system? Of course, sun is the major source of light. So the frequency of light depends on the source of light. Frequency does not change on refraction. F remains the same frequency for that particular medium when the light ray travels, or whatever medium it is considered, either vacuum or the medium we consider. Frequency does not change on refraction. And we express the formula which is relating frequency and lambda value, wavelength lambda, and v is speed of light, is v is equal to f lambda. This is the formula expressing speed of light with frequency and wavelength. Let's learn about refractive index of the medium, or mu. The ratio of the speed of light in vacuum or air to the speed of light in that medium is known as refractive index. I repeat, the ratio of the speed of light in vacuum to the speed of light in that medium is called as refractive index. So here we can express refractive index as mu is equal to C by V, where mu is refractive index is equal to C is speed of light in vacuum divided by speed of light in that medium. So speed of light in that medium, we have taken whatever medium we consider, either air or water. But speed of light in vacuum, we know the value of speed of light in vacuum. How much it is? 3 into 10 to the power of 8 meter per second. Next, we shall see few numericals to solve here. The speed of light in water is 2.25 into 10 to the power of 8 meter per second. Find the refractive index of water. So, since the formula is written above, I am not repeating here. We know that what to be calculated here, the refractive index we have to calculate. Hence, refractive index of water, mu of water we have to calculate. So, mu value is C by V. Just substitute for C place. C is the value of speed of light in vacuum, that is 3 into 10 to the power of 8 meter per second, divided by whatever the value is given for that speed of light in that particular medium. Here they have given speed of light in water. So, substitute that value, divided by 3.25 into 10 to the power of 8. 10 to the power of 8 and 10 to the power of 8 get cancels. Then 3 by 2.25, shift 2 zeros, add 2 zeros in the numerator. So, you can solve. On solving, you are getting the answer as 4 by 3 or 1.33. So, this is the answer. And where refractive index has no unit, it is of same unit of same quantities, like speed of light in vacuum is meter per second, speed of light in that medium is also meter per second, hence get cancels and no unit for refractive index. Next, on moving to the another sum, refractive index of water is 4 by 3. Find the speed of light in water. So, we know the formula relating speed of light in that medium and refractive index. Mu is equal to C by V. Here we need to calculate V value. Make V subject to the formula and bring this mu to the denominator, and V goes to the numerator. Hence, V is equal to C by mu we get, and substitute the values of this. What is C value? 3 into 10 to the power of 8 meter per second, that we know, divided by mu value is given as 4 by 3. And taking this 4 by 3 to the numerator becomes 3 by 4. On solving this, you get 2.25 into 10 to the power of 8 meter per second. So, this is the answer. Next, the refractive index of water is 4 by 3 and glass is 3 by 2. What is the refractive index of glass with respect to water? So, when you come across these kind of sums with respect to a refractive index of some medium with respect to the other one, normally when we write refractive index, mu value of water, mu of W we write. When we write in plain like this, mu of W, it is understood that it is with respect to air in general. If we express just a refractive index of glass, that is mu of glass, we write like this. It is with respect to what? If it is written plainly, it is with respect to air. It is understood in general. But whenever you come across two media like this, medium, glass with respect to air is, water is given to be calculated. Hence, how do we write this? Refractive index mu of G with respect to water. W you have to write this type like this. Okay. Remember this, mu of G with respect to water, glass with respect to water. Hence, we express it like this. mu of G with respect to water, and in the next step we have to express in the numerator refractive index of glass, denominator refractive index of water. Then substitute the values. G value, refractive index of G glass value is given as 3 by 2 divided by 4 by 3 value, and when you take this 4 by 3 to the numerator, it becomes 3 by 4, and hence on solving this you get the answer as 9 by 8, and on solving you get 1.125. And remember, refractive index has no unit. Okay, so in the following videos we shall continue with other topics which is given in the syllabus of optics. If you like the video, don't forget to give a thumbs up. Thank you.